Okay, welcome back. Now let's do another problem here, and let's go through a little bit faster. Okay, and so we've got a polynomial, so it's not a linear curve. So let's see how we approach this. So the way I would approach it is let's do the scratch work first, because we already know how the proof is going to go, but we need to figure out what delta is, right? So remember, we've got our x and a and our f of x and L. So again, we start with the absolute value of f of x minus L, which is going to be the absolute value of x squared minus 2x plus 3 minus 6. The absolute value of that difference is going to be less than epsilon, right? All we know at this point is epsilon is positive. But we need to get this to look like, right, we're going down here to try to get this to look like the absolute value of x plus 1. And less than something, right? So again, just keep an eye of the goal in mind. So now, let's simplify this and see what we get. So we get the absolute value of x squared minus 2x plus this will be minus 3 is less than epsilon. And then this is factorable, so this will be factored into x plus 1 times x minus 3 is less than epsilon. And then now I can split this up using properties of absolute value. I know that x plus 1 times the absolute value of x minus 3 is going to be less than epsilon. Now, it would be very tempting to just divide both sides by the x minus 3, since we know this has to be positive and this is positive, and use that as our delta, but be careful, you can only have delta defined in terms of epsilon and no other variables. Okay? So we're not going to be able to do that, but here's where we can bring in an assumption and put in a upper bound for delta. And again, the choice is arbitrary on what you choose. Now in some cases, some proofs, you have to be a little bit more careful about what you choose for delta, but in this case, it's not going to matter at all. So why don't we just choose 1? So let delta, so we're going to assume delta is less than or equal to 1. Now, when we assume that, then we also know that, hey, we know that we're looking for the absolute value of x minus plus 1 is less than delta, right? And now we're assuming that delta is less than or equal to 1. So now, if this is true, right, then obviously, if x plus 1 is less than 1, then of course, x minus 3 would be less than 5. Now, where am I getting 5 from? Again, I'm just arbitrarily picking a number. So if I know that x plus delta is less than 1, so x plus 1 is less than 1, the absolute value of x plus 1, okay? Right? So, since delta is less than or equal to 1, and the absolute value of x plus 1 is less than delta, which is less than or equal to 1, then what's the consequence? Well, then the consequence obviously we could show, is it x minus 3? Yes. Since this is true, then x, the absolute value of x minus 3 is going to be less than 5. Right? So obviously, if x plus 1, the absolute value of x plus 1 is less than 1, then it's obvious, right, that the absolute value of x minus 3 would be less than 5, right? Now, why did I choose 5? Again, it was arbitrary, okay? Because I want to replace this with a number, okay? In order to do that, I had to assume a value for upper bound for delta, okay? And so now, if this is true, right, then consequently from here, then let me think here. So x minus... Right. So if this is true, right, then what happens? Well, this incorporated with this gives us that x plus 1, the absolute value of x plus 1 times the absolute value of x minus 3 has to be less than epsilon, no, is less than the absolute value of x plus 1 times 5, right? There we go. That's what I want. And then at this point, we realize what delta needs to be. Right? Because here, right, this is less than this is less than this, right? So then this has to be less than epsilon, right? So this is less than this. We're putting a bound on it, which is then less than epsilon. So now we see that delta, in this case, for our choices, has to be, oops, not in the wrong one. Delta has to be equal to epsilon divided by 5. Okay, now, so we've got this, but we're also assuming that delta is less than or equal to 1. So what do we do? Well, we're going to do the same thing that we did before. We're going to choose delta to be equal to the minimum, right? Because whatever, it could either be 1 or it could be epsilon over 5. It just depends on what epsilon is, right? So we're going to choose delta to be the minimum of 1 and epsilon over 5. And so that's how we're done with our scratch work. Okay, now the proof. Okay, so now we start our proof. Let epsilon be greater than 0, right? Okay. choose delta to equal the minimum of 1 or epsilon over 5. And so now we're going to start with assume 0 is less than the absolute value of x plus 1, which is less than delta. Right? And so from here, we see that x plus 1 okay, so from, how do I want to say this? Hence, right? So hence, the absolute value of x plus 1 is less than 1, and the absolute value of x plus 1 is less than epsilon over 5. Now, since this is less than 1, then what? X plus 1 is less than 1 and greater than negative 1. Right? And then x is less than 0 and greater than negative 2. Now at this point, let's subtract 3. So x minus 3 is less than negative 3 and greater than negative 5. Right? And now we see that the absolute value of x plus 3 is less than 5. Right? So this is true. It's definitely saying that the absolute value, because this is going from negative 3 to negative 5, so the absolute value of this is less than 5, right? All right, so now what? So now, this gives us this, that the absolute value of x squared minus 2x, see, this is where it's a little different than before. So this gives us x squared minus 2x plus 3 minus 6 is what? Equal to the absolute value of x plus 1 times the absolute value of x minus 3. I'm going to erase my scratch work, because now we know that this is going to be less than what? We know that this is less than what? Epsilon over 5, right? That's this one right here. And this right here, no, right, where is it? Oh, right here, right? So here gives us this one, and then here is right here. So, which equals epsilon. Therefore, we're done. So now, therefore, the limit as x approaches -1 of x squared minus 2x plus 3 equals 6. And we're done. Have a great day.